Good morning, students. Let us continue from where we have left in the last class. Let us see few more concepts. Suppose a monoatomic gas is there. Someone asks you, what is the kinetic energy? So, the kinetic energy is given by 3 by 2 kT. If it is diatomic, kinetic energy is given by the expression 5 by 2 kT, where k is the Boltzmann constant. I think there will be a double n here. What is the value? 1.4 into 10 to the power of minus 23 meter square kg by second square Kelvin. Okay, so this expression you should know. All right. So while discussing few points yesterday, we were talking about that this is a system. This is what? This is a system. This is your environment, nearby surroundings. So here let us say the system, and this is the boundary. This is the boundary, which kind of acts like a barrier between the system and the environment. Like for the tea cup of tea, that cup itself is the boundary. Now here let us say this temperature of this system is Ts and environment is Te. So three possibilities were there, isn't it? So one is Te can be greater than Ts, Te can be less than Ts, or Te can be equal to Ts. The third case we said that it is thermal equilibrium. Thermal equilibrium. So in thermal equilibrium, basically there is no heat transfer. So the possibility of heat transfer will be in these two cases. These two cases are cases of heat transfer. Okay. Now, while understanding this concept of heat transfer, you imagine environment as another big body and this system as a body. The environment is all surrounding the system. Okay, there is air all around. You just imagine like it is another huge body. Okay, and its temperature is T, and this is your system whose temperature is Ts. So if temperature of the environment is high when compared to the system, the heat transfer will be in this direction. Okay, this is which case if Te is more than Ts. If Te is less than Ts, what will happen? You have to just see whichever is the higher temperature. So here Te less than Ts means Ts, from Ts to the environment, heat transfer will occur. So here we need to understand one thing, that this transfer of heat means transfer of energy. That means some work is done. So here when you say that environment has more temperature and it is giving some heat to the system, imagine this like a person. This person has some account. Okay, in his account there are 100 rupees. Someone has some 1000 rupees. He gave some money. What happened? This 100 became 200. Okay, so so work is done on the system. Heat is given by the environment to the system. What happens is, will you call this as a positive work or a negative work? Means it is the system is gaining heat. Here this person is gaining money. Here this system is gaining heat. Is gaining energy basically. Is gaining energy. You can call this as positive. Another situation where the temperature of the system is more when compared with the temperature of the environment. Let us say now this has got 1000 rupees. There's another person who has only 100 rupees. So he is giving some 100 rupees now. So he is gaining and he is losing money. So here, when the temperature of the system is more, the system is losing energy. Okay, so here it is losing energy minus. So this is the concept that is involved. Okay, so you need to clearly understand this. When the system is gaining energy and when the system is losing energy. For sign convention, it is helpful to us. Okay. Like you have taken a container, and inside that you have poured water. You are heating it. This heating process is happening in the surrounding. Surrounding is at a higher temperature. You have put this on a gas stove. It is at a higher temperature. So this fellow is giving heat. Now this is your system. What is happening? Initially, there was some kinetic energy of the molecules. But when you started giving this heat, what happened? The kinetic energy of the system got altered. So we have earlier seen that the sum total of all the kinetic energy of the molecules is called internal energy. So when you are giving heat to the system, there is a alteration in the internal energy. There is an alteration, change, badalav in the internal energy of the system. So why this change? Similarly, this system can be giving away heat in another situation. So what is happening? Is there a change in internal energy of the system? In that case also, there is a change in the internal energy of the system. Okay. So case 1, case 2. Here heat is given to the system. Here system is releasing heat to surrounding. In both cases, you will find delta U. So this is how it is. Okay. Now let us move on to the next topic. All right. One more point I would like to discuss. See, we take a piston arrangement. We take a piston arrangement. The diagram is something like this. All right. So this is your piston with some lever. This is your piston. It's a movable piston, massless piston, and frictionless piston, let us say. All these are ideal conditions. All these are what? Ideal conditions. So one thing, what is there inside here? All gas molecules are there, isn't it? Here, all gas molecules are there. So you give some heat to the system. What is happening here? When you give heat to the system, the internal energy gets modified, gets altered. When the volume is fixed, the pressure will be increasing actually, and it will try to push this piston that way. So initially whatever heat you give to the system is used for raising the internal energy of the system. And after that, it will try to push this piston out. So here gas is pushing the piston. Piston you can call, here everything is surrounding. Okay. So the gas is working on the piston. The gas is the system is working on the environment. So which type of work is this? It's a positive work. It's a positive work. We have seen an expression for that. W is equal to PV, I told you. Okay. You take the pressure, you take the volume change, you multiply with that, you get the work. If you consider a very, very small change in volume, you get a very, very small amount of work is done. Total work, if you want to get, you integrate this, both sides. All right, this is one way of altering the internal energy of the system. Now, let us say you push this piston. This is case 2 now. Case 2, what we are discussing? You push this piston inside. You push this piston inside. What is happening? This piston now will occupy a inner position like this, isn't it? Even there, you are altering the internal energy of the system. You are squeezing the volume. What will happen? The gas molecules trapped inside will experience a change in the kinetic energy, their average kinetic energy. So here what is happening is you are doing an external work. The work is happening in the environment and you are affecting the system. So this type of work, it is from environment to the system. Here the environment, you can call it as a piston. So what is this? You energy of the gas molecules, here the work, the type of work done will be negative. Okay. Here gas is putting pressure on the piston, that is positive work. Piston is putting pressure on the gas, that is a negative work. So try to differentiate these two type of cases. Okay, so this is one concept. Now let us move on to the first law of thermodynamics, because the background required for that I have just explained to you now. First law of thermodynamics. We have seen the zeroth law of thermodynamics, which states that if there is a thermal equilibrium, the system, there are two bodies in the system, both will be at the same temperature. If there are three, all three will be the same temperature. Now what does first law of thermodynamics says is, I'm going to the mathematical part. If Q is the energy given to a system, then some part is utilized for altering the internal energy of the system and some part is used to do the external work. This is the statement of first law of thermodynamics. This is the statement of first law of thermodynamics. Okay, what did I tell? You are supplying some 100 joules of energy to the system. Let us say some 40 joules are utilized for changing, altering the internal structure of the molecular arrangement of the system. You are altering the kinetic energy of the gas molecules. Thereby the internal energy is modified. What about the leftover? Some 60 joules is used to do some external work. Now here I want to say, let us say W is equal to 0. Just mathematically we will talk. What does this mean? Q is equal to delta U. All the heat that was given to the system was utilized only to modify the existing internal energy of the system. Okay, that means there is a body, you give 100 joules of heat. So here gas molecules are there, isn't it? Whatever heat was given, it modified its own internal energy. Let us say internal energy was earlier 10 joules, now it became 20 joules, let us say like that. It used for alternate. Don't see just mathematically, okay? So 100 joules means all the 100. Let us say the internal energy was 10 joules, now it became 110 joules. The difference is 100, all the 100, you don't consider this. All the 100 joules was used to heat up the system. See, when the internal energy is changing, basically the temperature of the body is changing, isn't it? What is temperature of an object? Is it not just the kinetic energy of the molecules in it? Okay. So this is scenario 1. There can be such scenario that there is no work done. That means all the heat supplied went for raising the internal energy of the system. Now, suppose if I say Q is equal to 0, what is happening? Delta U is equal to minus delta W or W. There can be a situation where no heat is given to the system. Where no heat is given to the system itself has uh, some of its own internal energy. That internal energy it is using to do some external work. See, here I am saying that 100 joules I have given to the system. Thereby, the internal energy got modified, and whatever left over is there, it did some external work, let us say. But there can be a situation, this system already had some internal energy. You have not provided any heat to the system. Even then, that internal energy after some time can be utilized to do some external work. But here you can see the sign convention. Delta U has become minus W. Why? Because this fellow, when he is doing some work, he is losing energy. Internal Babu is losing energy. External Babu is gaining energy. So as per our notation, it is a negative work. That is why this minus has come. Okay. So these are the interpretations of that first law of thermodynamics. Here we are essentially not talking about any losses. We are saying that 100 joules of energy was given, 40 went to the kinetic energy, raising the kinetic energy, internal energy, and remaining 60 joules was used to do some external work. Okay, but we are not talking about any of those losses there. So kindly note this. All right. The example, if you want to understand, there is some system like this. So here, let us say 200 joules of energy was given and work done was 100 joules or 120 joules. The work done by the system. So how much energy was utilized for raising the internal energy or changing the internal energy means delta U is equal to 200 and 120 gone, 80 left over, isn't it? Delta U will be Q minus W, 200 minus 120, which is 80 joules. Okay, so you can sometimes make this type of diagrams also, so that also helps you understand the scenario. This Q in another situation can be like this and like this. So here let us say I give 200. So what is this 200 here? It is minus. If this is 120, what is this? This is minus. So here also what is happening to delta U? It is minus 200 minus of minus 120. So it is minus 200 plus 120. It is minus 80 joules. Okay. Here what is happening? This fellow is losing energy. Okay. So these are two scenarios. Now look at this simple question which we have already discussed. It is given in the form of a statement. 104 kilojoules of work done on a certain volume of gas. Now this is that certain volume of the gas. And 104 kilojoules of work is done on the gas. It's like this. 104 kilojoules. 125 kilojoules of heat. The gas releases 125 kilojoules of heat. So this gas is releasing 125 kilojoules of heat. So you can make a diagram like this. It's asking you calculate the change in internal energy of the system. So the change in internal energy of the system was given by Q minus W. You can talk only the magnitude part, or you can talk in terms of understanding the system. So exactly what is happening here? This Q is negative here, minus W, it's work done on the system, so it is minus of 104, isn't it? So Minus of minus is plus. So this is minus 121 kilojoules. So 21 kilojoules of energy, was it increased or decreased actually? Think about it and you can comment. Okay, 21 kilojoules is the change in the internal energy of the system. What does this minus indicate? Just see the previous part and come to a conclusion whether it was the gain or the loss. Okay, so next class we will see some more concepts. So today I have covered the concept behind the first law of thermodynamics. Thank you for your time. Take care. Bye bye.